Okay, great. Having sought active consent and received some, then I will proceed with that. Right, thanks everyone for coming. And if I get my, oops, not that. I am, I lost my screen. Okay, this one? Nope. One moment, please, while I find my slides again. Uh, this. Okay, outstanding. Great. So why? Oh, first off, we are under the note well, the IETF note well. Please note it well, um, especially if you have any concerns over copyright or patent issues. Please review these documents before contributing. Anything you say here will be a contribution. Okay, with that said, uh, why I think this is important. So I'm going to show you just a couple of pieces of data of some of the stuff we're looking at. This first one is a chart of throughput of all the responses sent into a specific ISP on a normal day. And so each half-hour slot is a stacked histogram of what throughput was actually achieved by, uh, what proportion of the responses that were over 100 kilobytes in size actually achieved different levels of throughput. And as you can see, there's a reasonably stable across most of the day kind of distribution of throughputs achieved for these objects. And as we get into a peak of the day, it's sort of the slower transfers sort of take a bit of a higher share for a couple hours during the kind of peak of the day. And this is what we see for ISPs like this on a normal day, and this is reasonably typical. On a heavy traffic day, what we see is this instead. This is like 9 hours of half the throughput is kind of my basic take on it. So the user experience is kind of why I really started on this. The congestion here we think is a major contributing factor to what's going on. And this traffic is this increased traffic during a high traffic day is almost uniformly driven by things that can be shared. It's, this particular day there's like 3 or 4 new game releases that happened, and it had this kind of an impact on the people that were trying to use the internet in this ISP. This is not the traffic for those downloads. This is the traffic across um, all of the responses that are sort of big enough to respond to congestion for that day. And so this is one of the main driving factors. And the reason multicast is what we're looking at in particular is that there are things that you can't solve without sort of making use of these broadcast channels at layer one. There's a lot of the network problems you can solve by putting caches deeper. You can solve by increasing your cache sort of capacity and maybe in some cases making it closer to the end users. But there's a layer here that just can't be addressed without something like because receivers. So this is actually reducing, if you can do this with multicast, you can actually reduce the traffic on the wire for this kind of a setup. And this is like the way normal TV is delivered, but that's like because it's provided by the ISP, they can do that, right? I put just a sort of quick review here of the different kinds of layer one access technologies and how much offload you might be able to achieve by getting the traffic delivered with multicast over those hops. But that's the kind of you know so whatever percentage of end users are downloading the same thing at the same time in some shareable way, which we can talk about how much is that. Um, you can sort of distribute all those flows, across this sort of a size, roughly, you know. So the other big whys for this are basically, besides the user experience, is the climate impact, which is bigger than I had realized. The internet apparently consumes 3.7% of carbon footprint globally, and it's basically, if you can reduce the traffic, then you can, cut it back by something roughly proportional, we think. I don't have a great analysis of this, but I'm looking to save ultimately something like 1% of carbon footprint globally without an impact to the ultimate quality of service, and also to reduce the costs. So once this is, you know, there's going to be some work to get it deployed and to get it working. But I think once this is part of day-to-day operations, the marginal cost is not that high, and it means that the network capital costs can be lower, while still delivering the same sorts of things. The capital costs are driven by the peak load they have to handle, and that's once you can reduce that sort of thing, it ends up resulting in a lower price for users for the same quality of service, and that's really kind of what we're getting at. When we look at what kind of traffic for what we're delivering on these heavy days, we think we can do. This is just from our logs, so this is a sort of, we think of this as a pretty low ball estimate, but into an ISP, this is what we're delivering from our platform over the course of
Jake,
the
there are
day.
some questions in the chat.
Oh yeah. Let's stop and address them then. Some of the chat. Is climate, let me go in order here. Is climate impact mainly caused by power usage? That's a good question. I would refer you to the article that's linked there. That's I gave a can I back up? I gave the title, "Why Your Internet Habits Are Not as Clean as You Think." That was my interpretation. It's mostly driven by power usage. Especially the long transit links um, are more power heavy than people realize. Some of that is addressed by caching. I don't know of other. There's also like cooling, which is indirectly affected by power usage. Yeah, and then Spencer asks if we should record attendance in the side meeting. That would be great. So yeah, thank you. That's a great idea. I think Bitcoin mining is usually treated separately, but again, I guess yeah, that would call the idea into question. I Again, take a look at this article, and draw your conclusions from there. But I will just say that this is where I'm pulling this number from. Right, and I will keep an eye on the chat. I I started doing this before I knew about the carbon bit. I just believe it's useful to improve the efficiency. Regardless, this is the chart of the game downloads on that high traffic day. Into I think it was actually a different ISP, but or I should say this is of all the traffic into an ISP. The top line here is just sort of what we observe being sent. And the dark green part is the part that we believe could be offloaded if we were to use multicast for this delivery instead. We think of this as a lowball estimate for what's achievable because it doesn't take into account things that you could do to actively exploit the multicast-based delivery where it's available. So that we think it can be made somewhat more efficient than this. There's already some things where it's like spread across multiple days that maybe wouldn't have to happen or wouldn't have to happen to the same extent. But we believe that this traffic could just be shaved off the top in terms of what actually has to be sent, roughly, if multicast were ubiquitous. Similarly, this is what we saw for a reasonably popular sporting event. The blue line is what was delivered into an ISP just in general from our traffic. The red line is what we think it could have been had we been able to deliver that just one particular sporting event with multicast. So this is, we believe, substantial in terms of what, especially the sort of impact to end users under these kinds of conditions during, where it's during a peak. So, like I said, I put slides in here for the how we're proposing to do this. This is obviously still up for discussion. We have a few active drafts that propose this, that walk through this work. But roughly the way it works is by using some metadata that is published at a discoverable location, and then that metadata is used as a hook to authenticate all the traffic. So we're trying to address the security concerns from specifically from packet injection, which we think is the big one. We have several other security concerns outlined in the security considerations doc that went with this invitation. There's a few other things like how do you do the provisioning at different layers in the network and also at the endpoint. You can, like for the browser API, in the browser, you can fetch the metadata that says, well, how big is this thing going to be before you join it? And you can use signals that you've collected previously for, like, is this going to be bigger than what my network can support, and make a determination about whether or not to accept the multicast stream before propagating the join. And these are written up in a few documents that are active now in MBOND. I'll be talking about them tomorrow there. But they've been going on for some time, and we have some prototypes that we've been working through. This is kind of just the picture of what that authentication looks like. What we're doing is a secured channel that's sending hashes of the packets, cryptographic hashes of the packets over the secured channel. We link that with the actual received packets that we get, and we compare them to determine whether these packets are okay. The chain of trust, we can come back to if people want to dig into it, but I think most of this really has to be kind of addressed offline. The way the discovery works is there is a DNS component. If you are at the receiver and you have access to application level information, you can explicitly provide the host name for the dorm server, where you can find the AMBI part. That's part of the browser proposal because we don't have secure DNS. But the same metadata is available to on-path devices so that you can do authentication at the ingest before forwarding it through a multicast capable network. So this is all part of the specifications we're trying to do to kind of anchor this work. We've been working with some ISPs. We did 5 lab trials in the last year. We started last November. And we've concluded those. We've got some other ISPs that are looking now. We experimented with this on their on the devices they use in their setup to kind of make sure that we weren't leaving anything out that was critical for them. We tried it in cable fiber DSL. We'd love to get some experience with 5G and see if we can get the MBMS working, but we haven't hooked up a partner for that yet. Obviously, for this to be worthwhile for ISPs to invest in the ingesting of the traffic in the way we're defining, it's going to need to have receivers that are deployed that can receive it. The idea here is to accept traffic from outside of the ISP network. So, like as Akamai, we can, and as other people who want to publish traffic can stand all these things up according to the specs, and then any ISP who's deployed the sort of ingest capability for this would be able to, when receivers inside the ISP try to connect to it, then they'll be able to discover the metadata that they need to process it appropriately, and then pass that through with the multicast infrastructure they have to receivers natively receiving multicast traffic. That's the idea we're trying to get. The ISPs were more positive than we expected, really. Some of them are eager to see this happen to help them kind of reduce some of these peak load days that they've been having trouble with. Others are like, well, if other people do it, then we would be willing to do this too. We found a few that were like, well, we're not interested. We're but there's enough interest here from existing ISPs that we believe it's worth moving forward. It looks like, and the web API we consider critical for live video. Smart TVs actually, something like 60% of them apparently are using web APIs to receive the traffic. And if we can sort of get a good satisfactory solution in there that can be used by web applications, then we can start hitting the smart TVs with this traffic. I don't think there's any reason we can't do the sort of software downloads. We have a prototype that we do not through the web right now, but that we were using for part of the trials for how to do these the sort of large file things that are happening at the same time. There's a few specs that get into ways to do that. And we're talking to customers about how to integrate this. They would be if we had a web API that could do it, then they'd be have to be using a player that was making use of it in some way. So we'd be looking this also. We have a prototype running, a web page with a Chromium fork that can play video built by receiving multicast traffic. Oh, I see. Were any satellite ISPs asked? Not yet. That also would be neat. I think they're so far they're busy with some other things, I think, but and there might be some routing trickiness on the LEO satellites. I'd certainly be interested in talking to them, but I think it's a good idea. Satellite ISPs have not been asked yet. Let's see. We did run prototypes during the trial with geo-located customers of ours that provided video streams, and also with just some open source large file downloads that we used to sort of make sure that we could share the traffic appropriately. On the website, we looked into submitting a prototype to Chromium for our first experiment. That was rejected. The reasons it was rejected were based on the security model that we have so far is about just authentication. They said that we need to add encryption. This is part of what we've begun looking into. And even though with multicast there are some trickier parts for encryption in that you have to distribute keys. Those keys are going to be shared, so you're going to have a lot of receivers that are able to decrypt that content. Now, anyone who doesn't have the keys, though, it will be invisible to them. So there's some value in adding that. Was the claim? I think it's a reasonable claim. And so we're looking into that, and we think we've got some good leads on what to do next there. But that's part of the ongoing discussion. The privacy concerns. There's a joint exposure in the LAN. So for your next hop network, yes, please mute. We're getting a little bit of noise. Sorry. There's some privacy concerns in your for your exposure to your next hop network of what someone's receiving that are just very different from what you see with a TLS protected stream. And we're not sure how that's going to pan out, and kind of what the we don't want this to become a privacy or security debacle, and we're trying to take the right steps, and that's part of why we're seeking the feedback here. And then the suitability for checking it in as an experiment. This is why it was rejected. It's considered mixed content at this stage, and it needs wider consensus. So that's kind of what we're trying to do now is get that ball rolling. As a sort of attempt to nail this down, We've published a multicast security considerations document that specifically focuses on using it for web transport. That was in the original invitation, I believe. We think that the encryption part we might be able to start addressing with the quick and some of the quick work that's been done before. So that's kind of tentatively next on our list for integrating. Another option here might be to extend AMBI, but we haven't entirely decided. That's probably going to depend on the experiments with the existing implementations. And beyond that, we're just looking for, like, how do we best move this forward? And, is this a sort of, like, what's the consensus here? Is it a terrible idea and we should go away and stop trying? Is it a lost cause? Or, like, is this maybe not hopeless and we can get this to work after all? Multicast, to me, it seems like low-hanging fruit. Like, there's 1 billion devices out there that have the capability to do this, and there's no reason to me that we can't, leverage that. So with that, I'll open the floor for comment. Questions.
Thank you, Richard.
Let's see.
Yeah, Richard's got his hand up.
I've got his hand up. All right. I don't know how to drive this stupid thing. Yes, Richard, please.
Hi, can you hear me?
Yeah, I can hear you.
Great. Hello, good evening, or whatever time zone you're in. Good to hear from you, Jake. Yeah, I mean, we're enthusiasts about Multicast. As you know, we generated that internet draft to put HTTP3 objects over a multicast quick connection a few years ago. We've been trying to keep that alive at BBC R&D since then. And yes, that NGHQ implementation is a kind of reference implementation of our internet draft. So we're very happy for you to play with that. But what I wanted to talk about a little bit was the API, the browser API question, really, because that's something that worries us a bit. For us, this could be really great, as long as we don't need to change our application in any way. So anything that requires us to have some new JavaScript API or to interact with the network is a bit of a turn-off, really. Having to include some JavaScript library in our application. Really, when we designed the internet draft, we tried to do it in such a way that it could be completely transparent to the application. And I think unless you get that quality in your solution, it's not going to fly for application authors. Really, what you want is for the browser to discover that the things that you're requesting of a unicast could be retrieved from some multicast stream, and you want your browser to subscribe to that multicast stream on your behalf without any intervention from you. So that's why we had this alt service style signaling, which is not really the best way of doing it, perhaps, but it demonstrates this sort of concept where the regular web server just says, oh, by the way, this thing that you've just requested from me, you could be getting from Multicast if only you subscribed to this group address. And then the user agent can do that subscription on your behalf. And really what you want is for the user agent to be subscribing to the Multicast stream and caching the objects that it finds on it in its browser cache, so that when you come to request them from your application, they're already there magically, and it doesn't have to do anything special. So that's kind of the concept that we'd ideally like to arrive at, but we realise that there's some barriers to doing that. But I think you've done a really great job at creating an ecosystem a really comprehensive ecosystem that kind of addresses all of the moving parts. So the only difference really is putting all of those moving parts behind a curtain where we can't see them.
Sure. Yeah, I do think from the certainly from the video player perspective, that's the intent. So I guess I haven't. So your this next step might get me there, and I hope it does. I think that would be a good way forward. But I'm hoping that the uh, that sort of just use an updated video library as the underpinnings might work for many videos. Although I do take your point. I think it's going to be different for different providers, and it's a minus if you have to do anything.
And
And
by
so,
the way, right? I mean, this is not just video that stands to gain here, right? It could be your next download of Call of Duty texture maps, right?
right. Yeah, that's true. While I totally agree, I think that gets to be a little bit trickier in terms of like what are the application needs. I'm not sure. So yes, in the charter for our multicast community group, we did mention like the use of fetch, and I forget if we got service workers as a sort of later target for this. We would like to get into web transport first because we think that's going to be generically applicable. But I think this is going to be a multi-stage thing. That you're right. Ultimately, we're gonna want to have to get ubiquity. We're going to need to hide everything. But I think we can get some level of early adoption, even if we do integrate at kind of the player level and need some touching. And I think that the protocols are not really sufficiently well developed yet to get that deeper for everyone. From what I've seen. That's an opinion, but yeah, sure. Thank you. But I will certainly take that into account.
Thank you.
Great. I think Magnus?
Yes, I want to inquire. So you're primarily going after, so to say, a resource multicast model here, that the resource object is the focus for what you would get rather than more classical multicast?
Yes. Although, so I should say the current prototype implementation we have is a sort of it's up to the receiving application. You are going to receive UDP payloads, and so you can have, our web app does use an unmodified HLS player that copies from a local cache. That local cache is built inside the web app as having received UDP payloads that were provided by the browser API. So
Yeah.
I think that could be improved on. Yeah.
Yeah, but I mean, I was asking because I mean, I got the impression that, I mean, especially like looking at which we did in MBMS for mobile multicast, even if it hasn't been a big success, it went from being more classical to be very much focused on, okay, you download resources and that works for video and that works for other things if you just know to ask them in the right time frame and then schedule them or things like that, which we had policies, systems, etc. working. So, yeah.
Yeah. So I wouldn't necessarily rule that model out, but I think that it's especially on the northbound interfaces that has some troubles, and I think it opens up some new kinds of both technical and security concerns where you have to hand it off to this intermediary. So if you want to do this at scale, then each intermediary has to be kind of independently vetted. Whereas that's why we've gone this one first, in large part, is that we need to, we'd like to be able to authenticate at the receiver that we're receiving the data sent by the upstream without having to trust the pieces on the path. You have to sort of hand it off to the last hop if you want to do it through that northbound interface.
Okay.
All right, Kyle.
Yeah, I just want to go back to what Richard said before and what you followed up with. I would say that that if we could get to if we could get to transparency eventually, that would be fantastic, because you could potentially get applications to leverage multicast without requiring the developer to do anything. That said, I don't want to boil the ocean instantaneously. It'll take a while. I think getting support into the browser for multicast aware applications is the obvious first step, because there are plenty of those that we'll want to leverage, and that will also give us the ability to develop experience and protocols that will allow us to sort of learn what the right heuristics are for using multicast, or when it's inappropriate, or how we should do unicast fallback, etc. So I guess, like, I think that's a good goal to shoot for, but I don't think we should start there.
Yeah, and I also do want to point out that there are kind of networking considerations also that are to some extent making it transparent can be done, I think, just as well as non-transparent. But just because you want multicast doesn't mean the network's going to forward it, right? We're starting out basically everybody's in that boat today. But I think that's going to be the same even going forward, because if you have a lot of multicast streams, there's going to be enough streams that not every network hop can forward all of them. So it's going to have to make decisions on what it chooses to forward and what it chooses to not forward. And that's part of what the CBAC proposal tries to address here, is like, just on a sort of capacity and path based basis at different points in the network, it can verify that that should or should not go through. I guess that's a little bit sideways to the transparency at the object level issue. Yeah, there's also the transparency at the traffic level issue for, there's a number of existing apps that that can do multicast. I would love to support them in multiple different ways. But there's a few different places here, but really just getting anything that can be used ubiquitously would be great. Yeah, thank you. Tianji, did I get that right? I have the next person.
Checking. Can you hear me?
Yes, I can hear you.
Oh, okay. Hi. Actually, I have a question regarding the 5G you mentioned here. So the 5G is working on the architecture for the multicast and the broadcast service. One particular thing is, so far the consensus is to use the control plane for subscriber to join a multicast instead of using the data plane. And also in the 5G, it's talking about like using individual delivery mode or shared delivery mode. So that will be between the the RAN access and the UPS. So here, when you talk about that, for the video multicast video transmission, there are a lot of things are done on the mobile side, at least in our our market. So here, seems like you try to use the web, the browser, to do the work instead of for subscriber from the UE set to subscribe to multicast session. So here it seems like you are using the underlying some application like a Safari or whatever, the web browser, to do the work instead of the UE. Well, this kind of, at least in my understanding, kind of conflicting to what the 5G MBS architecture is trying to propose.
So yeah, thank you for the comment. I think you're right. In 5G, as I understand it today, and this is all kind of secondhand. I have not been participating in 3GPP, so I do really appreciate feedback on this point. I might have something wrong, but I guess I was talking to David Navratil, who's been around for some time, and last I saw in the latest TR17, as I understand it, both a transparent mode that uses regular IETF signaling for multicast, so that you can do sort of IGMP group joins and propagate just UDP streams. That is one of the modes of support, and the other is the one based on the northbound interface that was sort of carried forward from the 4G. I think both of these have some reasonable use cases. I certainly don't object to using the northbound interface, but we would prefer to use the transparent mode, IP-based forwarding of multicast traffic if possible. And this is one of the ideas we would like to get vetted with the 5G community now, or in due course of time. But my understanding from TR17 was that there is support for IGMP 3 source specific multicast that's targeted for inclusion, so that transparent UDP traffic can be forwarded.
Yes, IGMP will be used beyond the N6 interface on the UPF side toward the provider network. The thing here is like for the 5G MBS, but the control plane is like a UE decide to join some multicast session will be done through the 5G core network. So that kind of, I'm trying to associate how your proposal will be work. Since your web browser it's like an app running on the UE,
right.
And the UE has to do something by itself. So it's just like I'll try to think aloud here. Just to provide some information for you.
Mm-hmm. No, that's helpful. But and again, maybe I have it wrong. Yeah, if you could contact me offline, jholland@akamai.com. I would love to get a really solid handle on this and see if there's any experiments I can do in a 5G context that would help with this. But
I can add a little bit to that,
Richard,
maybe.
Yeah.
So my understanding is that that there is some discussion in 3GPP about supporting let's call them legacy IPTV type devices that use IGMP signaling. So I don't know, an IPTV set-top box, for example, that's plugged into a 5G residential gateway using Ethernet or something like that. So that legacy device only knows about IGMP signaling for joining and leaving multicast groups. So there is in that 5G residential gateway some interworking function that can translate IGMP signaling into the appropriate control plane signaling to do the joining and the leaving of the multicast groups. So I think that might still be possible, the sort of thing that you're talking about. But there is a slightly wacky. I mean, yeah, the whole of 3GPP is a bit of a wacky world, really. But they have this ruse in 5MBS where it's actually the cellular base station that counts the number of people in each cell that are using multicast, and it can then choose whether to deliver those multicast packets over a point-to-point radio link or a point-to-multipoint radio link. It's a bit like how 802.11 Wi-Fi deals with multicast packets. Typically it will deliver them as a broadcast frame using the lowest modulation coding scheme. But if you can frig it, then you can get your Wi-Fi base station to replicate multicast packets and send them in directed frames to individual stations using a unique encryption key if you want to. So it's a bit similar to that, really, and maybe that's where they've got their inspiration from. But yeah, the other thing to add is that there is this whole kind of heavyweight infrastructure inside the 5G core dealing with dealing with the multicast services. So in the 4G system, it was called the BMSC, and in the 5G architecture, it's called the MBSF and the MBSTF. Two separate functions, one for the control plane, the other for the data plane, and then yes, there's all sorts of things downstream of that, like the MBUPF and things like that. But yeah, so that MBSF and MBSTF is effectively the gateway for your multicast packets. And if you're wanting to use this transparent mode, that's the point, that it connects outside into the real packet data network, what we would call the internet.
Yeah, that was my understanding, that this is one of the supported modes, as differentiated from sort of the original 4G. Although I think TR17 might have backported that to 4G also, at least on paper. I don't know the implementation status.
Yeah, I don't know what TR17 is. I've never heard of it, but certainly for I mean, the work that's going on in the moment in 3GPP. I mean, this is not a done deal yet. It's work in progress, right, for release 17. So the work on the architecture and the lower layers and the radio access network is largely wrapping up now, but there's a whole new piece of work literally just starting in a few weeks' time, looking at putting a user services layer on top of that basic infrastructure to enable this transparent ingest and maybe a more object-oriented ingest. And in many ways, what that object-based mode will be very similar to kind of what you're thinking of, really. So there will be a component in the core of the network generating a multicast object stream, and a component in the UE that's receiving that multicast object stream, very similar to the BMSC as was in the 4G system, and the MBMS client as was in the 4G system.
Yep.
And
you know,
that offers a degree of transparency, right? So you know they've kind of already solved the problem in a way that we're talking about like 5-10 years ago.
Yeah, this is actually. I wonder if there's anything that we could in the W3C multicast community group, maybe it should be added to a set of things that we're tracking, or a liaison. If we can get anybody that would be willing to join that group, I guess, and sort of help us navigate the 5G space, I think that would be really helpful. But yeah, I do think that's an important sort of network segment to accommodate, and I would love to make it work. I think it's worth doing even if there is some problem, but I would very much like to have this working in 5G too. Yeah.
I mean, you could argue that cellular radio networks are the killer application for multicast, if you think
I would
about
think
it.
so. Right.
You know, for GPON, right, going out to the far extreme, you've got well, in inverted commas, limitless capacity, right? So it doesn't really matter if you just splurge that on lots of unicast, in theory. But for a cellular radio system, your access network is using a finite resource, which is a spectrum, and there's only so much spectrum that you can buy at auction from the FCC or your local regulator, and yeah, so actually using that limited access network resource sparingly and efficiently comes with the greatest prize, if you think about it.
Yeah. All right. Well, great. Thank you. I think we are getting some suggestions to make sure that we're stopped at 5 minutes before the hour, which is coming up in about 5 minutes, I think. I think that's a good idea. MapRG won't wait on this. So any last comments, I guess, before we cut the line and adjourn?
Jake, I just had one thing. Don't end meeting for all, because we have to grab the chat notes before the meeting closes.
Great.
I have a question for about 3GPP and 5G. Which group in 5G is working on Web Multicast?
That's a
Yeah, there are
plural
a couple
answer.
of,
It's many.
yeah, there are a
but
couple groups. The architecture part is on the SA2, the architecture group, and there another on SA4. So yeah, but the main part is on SA2, the second.
okay, so it's SA2 and SA4.
Yes, yes.
Yes.
But the main part is SA2.
Okay,
So the SA2 work is kind of drawing to a close probably around September time, and they've got a specification called, it's TS, was it 23247, I think. So if you
do you
Google
know
for that,
do you know the document number?
TS
I put in the note.
23.247, I think.
Yeah, put in the note already.
23.247.
Yeah.
Thank you.
In the note you can check.
And
Great,
there's
thank
all
you.
sorts of work going on in the radio access network groups as well, but maybe that's kind of below our level of interest.
As one last, thank you very much. Appreciate the references. One last question I have for everyone here. Is this hopeless? Like, does anyone think that this is like a bad idea that we should not pursue? Thank you, Mr.
You should definitely pursue it and be positive about it. I guess the question would be, where would you go? I mean, do you try to present this in Quick? Do you present this in Web Transport?
Yeah.
Do you
I
present
think
this
we're
in
going to do some
PIM?
experiments. Yep.
We need a mailing list too.
I don't think it's PIM, but I do think. So we've got some things in Mbundi. I think maybe the security stuff and the so both the security requirements doc and perhaps AMBI. One option would be to go to Web Transport, I would think, if they'll have us. Another option would be to open a new working group dedicated to Multicast specifically, and sort of reopen MSEC might be an option. Yeah, I guess we're gonna probably try for Sec Dispatch and or a BOF next time is what I think, unless I can get some engagement from Web Transport and sort of consensus that this might fit in there. But that would require rechartering, so that's going to be a bit of a BOF anyway, I think. Anyway, I guess that will wrap it up then. Of those who chose to attend the meeting, no one thinks this is a terrible idea. Let's see, WebTrans might be busy. Yes, I know. I think we'd be behind the line for some of the other stuff they're working on, but as the sort of first target for where this could be in a web API, I think it would be a good fit from the web API side, certainly. So I would like to get at least something that can fit. Yeah. All right. Well, thank you very much, everyone, for coming. I really do appreciate it, and love the feedback. Thank you all, and I will see you around. Dream big, yeah. Thanks, Spencer.
We have to make sure to get that into the notes.
I'll do that.
I'm there for you, dude. As everybody leaves, I'll just say a happy thought, which is it does not require a BOF to recharter an existing working group, but it does require, like, reasonable charter text that the AD for that group agrees with. But
Okay.
but it doesn't require a BOF, and I can talk to you more about that if you're curious.
Sure, thank you. I will have to be reviewing some of the process on what to do to get this to work.
Oh God, don't do that.
Yeah.
Just talk to me.
Just talk to you. Great.
Actually, talk to Magnus because he's been an AD more recently than I have. But
Fantastic.
you know, talk to us, man.
I will do that.
You're not alone. You're loved. You're not alone.
Thank you, Spencer. Much appreciated.
Bye,
All right,
guys.
I'm going to turn off the recording. Bye.